Dear students, in this video we are going to discuss about first order logic. We already discussed declarative statement, that is true or false statement. We are going to again discuss the same with some syntax and semantic. So we call this as representation revisited. Declarative sentence is nothing but true or false statement. Bangalore is capital of Karnataka. You all know it is a true statement. So, when I include such a declarative sentence, we need a logic to communicate to the computer. That logic is called propositional logic. What is that meaning? Propositional logic is a logic which we are using to communicate to the computer that represents only declarative sentences. Sir, what about these sentences? All students of A department are smart. Match between RCB and CSK tie. All squares adjacent to pit are breezy. I don't think so it is a true or false statement. Then they are what type of statements? Above statements are expressive statements, partial information statement, and the last one is probabilistic statement. These are all not declarative sentences. So, we cannot use propositional logic to communicate to a computer for these statements. Then, what is the new representation we are having to represent above statements? They are propositional logic. Other than that, we have first order logic, temporal logic which deals with times, probabilistic logic which is nothing but degree of belief. What is the probability that it is true? Fuzzy logic, degree of truth, how perfect the statement is. These are all different types of representation we are having, which is ontological commitment. What we are having to communicate to the computer. First order logic. Most of the sentences which is available in natural language, it is enough to represent first order to communicate to a computer. That is what we are trying to say. First order logic is a technique for knowledge representation, that is communicating to a computer, and it is strong enough to represent any natural language sentence. First order logic is also known as predicate logic. What do you mean by predicate? It is going to give some base statement, establishment statement, something like foundation. So we call this first order logic FOL as predicate logic or first order predicate logic. Let us have syntax and semantic of first order logic. We are going to define a statement now, and I will tell who is subject, that is called base, and who is predicate in this particular statement. Rectangle is a polygon. Listen carefully the way I am reading. Rectangle is a polygon. 5 is an integer. No, don't read like this. Rectangle is a polygon, which means I am going to talk about whom? Come on, very good. Rectangle. I am talking about rectangle. And who is this rectangle? It is a polygon. 5 is an integer. Who is 5? 5 is nothing but what I am going to talk. We call it as subject. Okay. So, in these two statements, rectangle and 5 is nothing but subject. Who is rectangle? Sir, it is a polygon. Okay, polygon is a multi-sided geometry. Who is 5? Sir, 5 is an integer, sir. It is called predicate. So, for any statement, you should know who is subject, who is predicate. Now, what is the syntax we are having? Always represent subject within bracket and predicate outside the bracket. Okay. What is now the syntax for these statements? Subject you put within bracket, predicate you put outside the bracket. So, Blind, if you read polygon, rectangle, integer, 5. Okay. A first order logic engineer should read rectangle is a polygon, 5 is a integer. Since it is just artificial intelligence, we are not going to concentrate more on grammar. Rectangle is always a polygon, rectangle was a polygon, rectangle must be a polygon. Whatever you want you can tell. But what is the concept we learnt here? Rectangle is a polygon, 5 is a integer. We'll discuss some more statements. X is red. Apple is red. X is father of Y. Now I am talking about whom? X. So X is a subject. Red within bracket X. Yes, very good. Who is X? X can be a book. X can be an apple. So X can be anything. So we are going to call this as a variable. But now here very clear. Apple is red. So red within bracket apple. What it says? Apple is a red. Now who is apple? It can be anything or constant. Yes, it's a fixed one. You are right. Apple is a constant. Now whom I am talking? I am talking about X as well as Y, and I am trying to say X is the father of Y. So here predicate is nothing but father who will come outside. Who is X? Subject. Who is Y? It is also a subject. So whenever I have two subject, what is the syntax? Simple. Father within bracket X comma Y. So remember, whenever two subjects are coming inside here, for example, two variable, start from first variable, come to predicate, go to the second variable. Repeating, start from first variable, go to predicate, come to the second variable. Come on, very good. X is a father of Y. Okay, that is the way you have to represent. X is a father of Y. Okay. Let us have some more statements. X has value 50. I am talking about X and I am talking about 50 and I am talking about value also. So value is the predicate. Am I right? X and 50 are the subjects. So come on. X value is 50. X has a value which is nothing but 50. Whatever you can tell. Okay. Similarly, friend is a predicate. Virat and Dhoni is nothing but the subject. Okay. Very good. So friend within bracket Virat and Dhoni. Virat is friend for Dhoni. Virat is always friend of Dhoni. Whatever may be. Cats likes fish. I hope now you can tell. Come on. Very good. Cats and fish are syntax. Okay. That is nothing but subject. Likes is nothing but predicate. So who will be outside? Come on. Likes. Likes within bracket cats fish. That means cats likes fish. Okay. Simple logic. We are going to discuss one more new statement. Cats likes fish. I hope all the cats likes fish. So I am going to bring one new term called all. So we call this as a quantifier. We call this as a quantifier. All students like cricket. Very good. We call it as a quantifier. I hope very few students like engineering. Then it is called there exist, which means whenever I use the word for all, it represents many. Whenever I use the word there exist, it is nothing but very few, one or two, only one, something like this. So how to represent here? This term all is nothing but quantifier. Time being, don't see this particular all. Okay, completely don't see this particular all. What you are seeing? Cats likes fish. Okay, very good. Now what you should say? Cats likes fish. You represent likes cats comma fish. But whenever quantifier is coming, don't use the word the subject cats. Use a variable x. So okay, remember. So x likes fish. Why you may ask a question, sir, why you brought x? This is the rule when you bring a quantifier. Whenever you bring a quantifier for all or there exist, you should not use the subject directly. You should use the variable. Okay. So come on, read. X likes fish. Now you will ask a question. Sir, who is X, sir? Obviously X is a cat. So write down like this. X is a cat. Simple logic. X likes fish. Who is X? X is a cat. One X or many X? Many X. That's what we represent for all. Remember, this is a symbol. A, if you put reverse, inverted, it is called for all. This is called the symbol for the quantifier, which is called universal quantifier. Okay. For all X. For all X, where X is cat, X likes fish. Now, whenever we bring for all, there is a rule, there is a syntax. You should bring implies. You should bring implies. Please remember. Now, what is it implies? If then. Okay. Whenever you say implies, if this statement, then this statement. Okay. Now, I am going to read this carefully. For all X, if X is a cat, then X likes fish. Okay, that is what the statement. For all X, because of implies, if then is coming. If X is a cat, then X likes fish. Let us have one more statement. Now it is not for all, it is not everybody, only very few students. There exist, okay, some students likes ice cream, okay, not all, some students. Now let us see what is the syntax. Kindly don't see this sum, read remaining. Students likes ice cream. X likes ice cream, okay. Don't, instead of cat I used X, instead of student I am using X. Simple. X likes ice cream. Then the same question you should ask. Who is X? X is a student. Many student or one student? One student. There exists X. Now the letter E is inverted now. Okay, E. For all A is inverted, exist E is inverted. Okay. So let us this statement. This is the syntax. Now what does this represent? There exists X. X is a student. X likes ice cream. But something is missing here, sir. Whenever we use for all, implies. Whenever you use there exists and, okay, that is called conjunction. Now, writing this statement is little bit complicated. Now, let me show the statement. There exists some X. There exists some X such that. Whenever you use there exists, you should bring such that. This term conjunction is coming here, okay? And X is a student coming here. X likes ice cream. Since I use the word and, this X is included. So X is also likes ice cream. That is the meaning. Okay. So now let us recall. Some students likes ice cream. Don't use the word some. Recall, students likes ice cream. X likes ice cream. Simple logic. Next, who is X? X is a student. That's all. All students or few students? Few students. There exist. Okay. Inverted E, X. Now, whenever we bring here, you should bring conjunction, that is called and. Now, what is the statement? This is called semantic. This is called syntax. Okay. We told syntax and semantic. This is called syntax. This is called semantic. This is an English statement. There exists some X such that X is a student and also likes ice cream. You can also say X also likes ice cream, like whatever may be. Okay. Let me show few basic elements of first order logic. The basic elements are X, Y, we discussed variable, A, number, apple, they are all called constant, likes, brother, father is called predicates. We can also use equality symbol. We can also use some mathematical functions, square root, sign, less than, greater than. Quantifiers we know for all there exist. Anyhow, we discussed just now. Connectivities we already discussed. Again, I am repeating: negation, conjunction, disjunction, implies, biconditional. Okay. With this, I would like to conclude this video. We'll discuss more detail about quantifiers in the next video. Thank you.